Here's page 2 now, and this is all multiplication, so we can multiply in any order we want. I'm going to do the a's times the a's, the b's times the b's, etc. A to the third times a to the invisible first, a to the 4. B to the third times b to the 4, we get b to the 7. And let's not ignore the c. It doesn't change since there were no other c's to interact with it. Go slide over to the right here. Again, it's just a monomial times a monomial. We'll multiply the coefficients together and get negative 22. And a w to the third, there's no other w's, no change to the w. Z to the first times z to the fourth, get z to the fifth. And don't lose the little variable p. And if you're wondering, is this the only right answer? No, you could rearrange the letters in different orders. It would be the same thing, because it's all multiplication. But negative 22, and then what you see there. No need to read all that. Here's 3 monomials multiplying together. There's a 4 times a 5 makes a 20. And x to the third times the x to the fourth makes it x to the 7th. There's one more, kicks it up to x to the 8. Y squared times y to the first makes that a y to the third, times another y makes it y to the 4th. And there's a z, or z if you're Canadian. A z to the first times z makes z to the third. And that takes care of everything, right? We got the numbers, we got the x's, we got the y's, we got the z's. There's the answer. And the last one of this type, negative 3 times 5 is a negative 15. Times a negative 2, we get a positive 30. Then we got an x to the first, x to the third makes x to the 4th, times another x to the 4th makes it x to the 8th. Let me cross these things out as I use them up. Make it a little more organized. Y to the 6th times y to the 7th, that would be y to the 13th. One more, makes it y to the 14th. Finished with the y's. And there's a z to the 5th, z to the 1st, makes z to the 6th, z to the 6th times z to the 2nd, z to the 8th. And I put a little line through my z to make it look different than the way I write a number 2. Okay. On to another property of exponents. As it says here, what if we had to write x to the third squared and there were no such thing as an exponent? Let me address that right up here in this nice big empty space. Well, this little 2 on the outside is telling us to write x to the third times x to the third. And then we would just add that exponent, 3 plus 3, and get 6. Let me do this one the same way. The little 4 on the outside is telling me write x to the third over and over again. How many times? 4 times. So using the property from the first page, we just add 3 plus 3 plus 3 plus 3, x to the 12th. We're repeatedly adding the same number over and over again. Long time ago, you learned a shortcut for doing that called multiplication. Notice I could have just multiplied the exponents and got the answer. Same here. Multiply the exponents, you get the answer. And this shows you why, because you're going to write the inside exponent however many times the outside exponent tells you to. So like you'll have 4 3s or you'll have 2 3s. So in general, when you have something to a power, raised to a power again on the outside of the parentheses like that, in this situation, you multiply the exponents. And that makes things very easy. Well, x to the 5th to the 2nd, that'll be x to the 10th. And x to the 7th to the 6th, that'll be x to the 42th, or 42nd. 7 times 6, 42. Okay. I'm getting just a little uglier down here. This, if I didn't know my shortcut from just moments ago, the little 4 directs us to write 3x squared, 3x squared, there's a times dot, 3x squared, 3x squared. Oh, if I think of this another way, this is 3 times 3 times 3 times 3. That's 3 to the 4th power. And the x to the 2 to the 2, 2, 2, that's x to the 8th again. So what's new here, what's different here, is we have this coefficient 3. So notice what happens to the coefficient. It gets raised to whatever power is outside the parentheses as well. So let me write the answer over here because I've made a mess. 3 to the 4th power, if you multiply that out or use the calculator, 3 times 3 is 9, times 3 is 27, times 3 again, so all the way up to 81. So this is 81x to the 8th power. Okay, 81x to the 8th. And the rule is, it's simple enough, whatever's in the parentheses here raised to the outside power, the coefficient, A represents the coefficient, the A would get raised to the outside power, and for the variable part we would still multiply the exponents like we did previously. Now, what's new here? I guess you'd call this new. You got something times something times something. You got 3 things in there being raised to the 3rd power. Well, if we wrote this out, obeying the instructions of the outside exponent, we'd have 2x to the 5th y to the 7th times 2x to the 5th y to the 7th times 2x to the 5th y to the 7th. So 2 times 2 times 2, that's the 2 to the 3rd, and x, 5, 10, 15, and y, 7, 7, 7, makes that 21. So you see what happens here. You got more than one variable. Just treat it the same way you would one variable. You multiply the exponents. If there's a coefficient, the coefficient also gets raised to that outside the parentheses power. So this is, what is 2 to the 3rd? That's 8. So this is 8x to the 15, y to the 21. Oh, I'm sorry, I went off camera, didn't you? 2 to the 3rd, 8, x to the 15th, y to the 21. So this little property recorder down here, if you've got more than one variable, just take easy, as long as it's multiplying in the middle. Let me just point this out right now. If you've got something plus something to a power, that does not work like this. We'll talk about this again some other time. That means you got to write out x plus y, x plus y, x plus y n times, and you have to use the distributive property. It gets a little bit messier. So it's not the sweet little shortcut like this. So this would be x to the inside times outside exponent, mn, times the other variable, y to the inside times outside exponent, pn. X to the mn, y to the pn. Okay, that's the end of page 2.